All right, let's talk about enzymes. So enzymes are just biological catalysts, which means they speed up chemical reactions in our bodies. When we name them, we usually use the suffix ase, so for example, if we have hydrolase, you know that speeds up a hydrolysis reaction. If you have a polymerase, you know that speeds up polymerization reactions, like for example, used to make DNA, right? So important things to know about enzymes is A, they're made of proteins. Second thing is that they only work on energetically favorable reactions, which if you recall means that they have to increase entropy or be exergonic. So delta G needs to be negative. Reactants have high energy, products have low energy. So there's two types of reactions that would be catalyzed by enzymes. So either just exergonic reactions or coupled reactions, which overall are exergonic, even though they contain a part that's endergonic. So what enzymes do is that they don't actually affect the delta G part, so that's just the reaction. But for any reaction to occur, there's kind of this little energy that you need to get through so that the reaction happens. And this is what we call activation energy. And enzymes, all they do is lower the activation energy. So normally this would take a lot of energy, and it would happen, but it would take a long time for this reaction to occur. In our bodies, these chemical reactions, it's important to remember that they're sustaining our lives. We can't just sit around and wait for this reaction to occur because we need that reaction to happen quickly so that we're able to breathe and move and live and stay alive, So all it does, the enzyme, is lower this activation energy, so that's much easier to get through, and then the reaction will occur much faster. Again, this is energetically favorable, so it would have happened anyways. This just speeds it up. Now, enzymes also do not change the point of equilibrium of a reaction. So what I mean by that is that reactions can happen in two ways. So for example, it can go from red to blue, or it can go from blue to red. So if an enzyme comes into play, it's not going to increase one direction more than the other. So if I increase this by a couple of arrows going this way, well, the enzyme is also going to increase the other side by a couple of arrows going the other way. So how enzymes actually work is that they're kind of like this, the enzymes, and then they have this specific shape, and there's this part called the active site. Now this is where the substrate, or just the reactant, will bind at the specific site. So there's specific enzymes for specific substrates. We call that kind of like the lock and key hypothesis. So this shape has to really closely match the shape of the active site, otherwise it won't fit and the enzyme will not work. So in this case, it did. And then when they combine together, we call that an enzyme substrate complex. And that's when the catalysis will work, that it's lowering the activation energy. And then the enzyme kind of changes shape a little. It kind of just gives a big hug to the substrate, and we call that, in science, we call it induced fit. And then after that, at the end of the reaction, we get our products and the enzyme. Let's go, it's time to move on. Now it is back to its original shape. Note that it did not actually end up being part of the products. Enzymes speed up chemical reactions, but they don't actually partake in them, in that they don't become part of the products. They're just not part of the products. And now this enzyme can go back, see new substrates, and be reused again and again until eventually it wears out.